Hello, everyone. So hopefully by now you have done your 20 minutes of Alex. We are now going to look at the warm-up, kind of do things a little out of order. But if you have not done your Alex yet, please go and pause this video, go do your Alex now. Your warm-up today is these four problems. Go ahead and take a second to complete these on your warm-up paper. Okay. So number one says which ones are scaled copies of the original. So if you think back to seventh grade, scaled copies means that every side got multiplied by the same amount to change the size of the shape. Um, but the important thing about every side being multiplied by that is the shape looks the same, just smaller or larger. There's not kind of going to be one side that gets longer while another side doesn't, or one side gets bigger by a different amount. So if A here in the corner is the original figure, I want to look at figure one to see if that one is a scaled copy. So you can see that proportionally, um, the shape stays looking the same, just got smaller. So figure one is a scaled copy. Figure two here, um, this one side has gotten longer. This side got even longer than the other one, and your angle and the point of the A is not the same angle. Scaled copies have the same angle measurements. So figure two is not a scaled copy. Figure three almost looks like a scaled copy, but if I'm paying attention to the dimensions of the sides, from this point to this point, it's 2 square units. From this point to this point on figure three is also 2 square units. While the shape here, the height got larger, the base stayed the same, so it is not a scaled copy. And lastly, with 4, the width got larger, the height got larger by the same amount, and our angle stayed the same, so figure 4 is a scaled copy. Number 2 says identify what type of angle this is. This is a smaller angle, less than 90 degrees, so it is called an acute angle. Okay, number 3. It says the goal on number 3 this week is to multiply whole numbers with fractions. So whenever you're multiplying a whole number and a fraction, all you have to do is multiply by that top number. So 2 times 1 is 2, and then the bottom number stays the same because if I turned 2 into a fraction, it would be 2 over 1. So every time you do a whole number times a fraction, you multiply by the top number, the bottom number stays the same, and then you simplify if you can. So this is 2 over 2, which is equal to 1. You can also look at this one as what is half of 2, and that is 1. Okay, this says describe the transformations in a complete sentence. Unfortunately, my screen is not showing you the whole image. So let me try that again. Okay. So notice here we have 2 different transformations right off the bat. It is a sequence of transformations here because you can see the shape has flipped from the left to the right over the y-axis, but the C's don't match up. The C's are not on the same level on the y-axis. So that is why it is 2 types of transformations. It is a reflection. I'm trying to type on my screen. Reflection and a translation. So the reflection is over the y-axis. The translation, the 2 C's are 2 units down. So the reflection is over the y-axis and translation is 2 units down. So our complete sentence is triangle ABC was reflected across the y-axis and translated 2 units down to form triangle A prime, B prime, C prime. Okay, I don't know if you can actually see that writing, that sentence there, but if you did not get your complete sentence for that one, please go ahead and pause the video and copy this down. Okay, so we are now going to look at our notes for today. So please take out the notes paper from that the substitute gave you. And today our learning goal is to describe if two figures are congruent just by looking. Okay, so the definition of congruent is kind of what we have to do first. So one figure is congruent to another figure if it can be moved in translations, rotations, and reflections. We call these three transformations rigid transformations because these three are what keeps a figure congruent. So our facts and characteristics, we have three that we need to fit in here. So number one, corresponding sides are congruent. Corresponding angles are congruent. And lastly, equal area and perimeter. So you have to have these three things in order for the entire shape to be congruent. So you can have shapes that have congruent sides, but the shape itself wouldn't be congruent because it might not have one of these other two. You could have a shape with corresponding angles that are congruent, but the whole shape is not congruent because the sides or the perimeter. Oh, that should say equal area and perimeter. So sorry there, guys. Um, but these two things could be wrong. So you need to have all three things in order for the entire shape to be congruent. So a congruent shape, let's go ahead and choose, I don't know, some funny kind of looking box thing that we've seen on some of the other ones, on some of our other activities. So let's just call this like side 1, 2, 3, 4, and 5. Okay, those are Roman numerals if you can't tell. Um, and this is my shape A. So let's say that I rotate this shape slightly. I'm going to rotate it this way. If the shapes are congruent, this side, this side, this side. Oh, shoot, I did them wrong. This side, this side, this side, this side, and this side are all corresponding and congruent to the other one because I rotated it. I could then also reflect it. Again, pretend like all my sides are the same measurements. This one, this one, this one, this one, and this one would be congruent because all I did was change these transformations here to the shape. That is slightly confusing, but the whole point of this example is not the sides that I did necessarily. These little things I did on the sides are basically saying that each side that has that same measurement or that same symbol are the same measurement. So in order for the shape to be congruent, the sides on them have to be the same, the angles on them have to be the same, the area and the perimeter on them have to be the same. So not congruent examples would be a shape that is like this. Again, this is saying three different sides. A shape that's like this. This one is saying that all of these sides are the same. Or you could even have like a shape like this. Notice that my angle measurement here is not the same. And neither are my side lengths necessarily. So these triangles are not congruent because the angle measurements and the side lengths are not the same. Okay, so here are some additional facts about congruent figures. We do not need to check all the measurements to prove two figures are congruent. We have to find a sequence of translations, rotations, and reflections that match up the figure. So the main thing that we are going to be working on in here today and tomorrow is, yes, congruent figures have the same measurements, but we are going to have to use transformations to explain that they are congruent, not that not the measurements being the reason that they are congruent. Two figures that look like mirror images of each other can be congruent. There must be a reflection in the sequence of transformations that matches up the figures. So just like in the warm-up, you had the two triangles that looked flipped but didn't line up. Because they were flipped, there is a reflection in that. Two polygons that have the same area and the same perimeter are not always congruent. So again, you have to have all three of these other facts and characteristics in order for the whole shape to be congruent. You can have shapes with the same area and perimeter and it still not be congruent. Okay, so now that you have done your notes, we are going to go ahead and look at our Desmos for today. Where is my Desmos screen? Okay, so your Desmos today is called Are They the Same? I know it says discuss. We are not discussing because obviously you guys are listening to this video and not talking in class. So it says here are six pairs of figures. Select all the pairs with figures that are the same. So look inside of each one. Is this the same as this? Is this the same as this? Is this the same as this? And so on. So go ahead, take a second, select all the pairs with figures that are the same. Okay, so you can come up with different reasons for each of them. You could say that they're the same type of shape, they have the same number of sides. Um, this one F here has two triangles that make it. It's just not the same actual physical shape. So again, many different reasons for selecting any of them. But if we're going based off of whether they're congruent, the angles are the same, the sides are the same, the shape as a whole has not changed, and you can use transformations to get it there. That would be A, C, and E. B is not congruent because it's not the same size. D is not congruent because they don't have the same angle measures. And F is not congruent because it's just simply not the same shape. But A, C, and E, you are congruent, they are the same, and you can use different transformations to match them up. So because I just went over all of that, I now want you to move on to slide 2 and continue explaining what we said. What are some reasons that these ones are the same and these ones are not the same? Okay, number 3 here. One figure is congruent to another if it can be moved with translations, rotations, and reflections to fit exactly over the other. Select all figures that are congruent to figure A. Okay, so notice that all of these, every single one of them, they have the same area and the same perimeter. But you cannot match all of them up using the um, 3 types of transformations. So from A to B, I can rotate it and reflect it. So the shape itself is flipped and it's facing upwards. This little square here matches up with that square there. C, I cannot do because if I was to reflect it twice to move it over there, this little square is 1 over from where this one is. This one's in the middle. D to A, that is just a reflection over. You can see that this square would match up to this one if it was flipped. A to F, if this was to be rotated down, this little square would not match up with this one, as this one's perfectly in the middle, and that square would be up here. And lastly, A to E, it is a rotation, so this is now facing downwards, and it would match up because this little square matches up with this one. So figure B is congruent to figure A. Describe a sequence of rigid transformations that would move figure A onto figure B. Go ahead and type that in here. Describe a sequence of rigid transformations. Describe a sequence of translations, rotations, and reflections. Make sure you are using complete sentences. Okay. I do not know how to say this kid's name. Kwiku says that figures A and G are congruent. So A and G here. Land says that figures A and H are congruent. Whose claim is correct? Go ahead and answer this on your own. Okay, so part of it being congruent is I can use rigid transformations, our translations, rotations, and reflections to match them up. A is obviously a 180-degree rotation to get to G, so it has been rotated. H, however, would not use translations, rotations, and reflections because none of those change the size of the shape. The shape does not get larger or smaller with those 3 transformations. So A to H, the shape would have to get bigger. And that does not happen with those transformations. I want you to now complete this card sort of which ones are congruent and which ones are not congruent. Okay, I'm going to check through this to see how well you did. I will say that it should be, it's not even an even amount. So you will have three in one and two in the other. Hmm. Okay, so from this one to this one, which sequence of transformations could be used to show that these two figures are congruent? Go ahead and answer this one for me, please, on your own, so I can see how well you actually understand your sequence of transformations. And then this says select a sequence of rigid transformations that could be used to show that these two figures are congruent. Again, go ahead and try this one so I can see how you do with it. So, synthesis, looking at the six shapes you were looking at before, how can you determine whether two figures are congruent? Explain this in your own words. How can you tell me which of these cards from the very beginning were congruent ones? I am so sorry, I'm coughing so much. Okay, slide 10. I want you to tell me is A and B congruent? So again, these last few slides I wanted you to do completely on your own so I can see where you are with this. And then lastly, go ahead and answer um, these questions here. If you are finished already in class, please go back to Alex. Keep working on Alex and make sure that you put your notes paper that we did in your binder. Bye, everyone.